Data link layer. The data link layer transforms the physical layer, a raw transmission facility, to a reliable link. It makes the physical layer appear error-free to the upper layer. This figure shows the relationship of the data link layer to the network and physical layers. The data link layer is responsible for moving frames from one hop to the next. Other responsibilities of the data link layer include the following. Framing. Data link layer divides the streams of bits received from the network layer into manageable data units called frames. Physical addressing. If frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the sender and network. The receiver address is the address of the device that connects the network to the next one. Flow control. If the rate at which the data are absorbed by the receiver is less than the rate at which the data are produced in the sender, the data link layer imposes a flow control mechanism to avoid overwhelming the receiver. Error control. The data link layer adds reliability to the physical layer by adding mechanism to detect and retransmit damaged or lost frames. It also uses a mechanism to recognize duplicate frames. Error control is normally achieved through a trailer added to the end of the frame. Access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any given time. Hop-to-hop delivery by the data link layer. As the figure shows, communication at the data link layer occurs between two adjacent nodes to send data from A to F. Three partial deliveries are made. First, the data link layer at A sends a frame to the data link layer at B. Second, the data link layer at B sends the frame to the data link layer at E. Finally, the data link layer at E sends a new frame to the data link layer at F. Note that the frames that are exchanged between the three nodes have different values in the headers. The frame from A to B and has B as the destination address and A as the resource address. The frames from B to E has E as the destination address and B as the source address. The frame from E to F has F as the destination address and E as the source address. The value of the trailers can also be different if error checking included the header of the frame.